Welcome back. This is video 3 of the Ansible tutorial. Again, my name is Doug Webb. I'm a network engineer with Northrop Grumman. Okay, so we have talked about our Ansible setup, how we talk to our targeted devices, and how to configure some basic things on network devices. So let's talk about a few more things we can do with network configurations as well, and how we can manage our networks more efficiently. In a DevOps environment, you will want to get familiar with Git operations and version control, but for now, we're just going to talk about how to create a single centralized platform internally, and we'll focus on Git in later videos. But in this video, we're going to talk through the use of an additional Ansible module called the iOS ACL interfaces module to configure a few access control lists that we want on our routers. Then we will talk about how to configure our network devices using Ansible to call on full configuration files. And then we will back up our devices to a local folder by date so we know when the last time we backed up our devices. And then we will then talk about some debugging methods to output information we need to know to terminal. And then we will hop into some Linux host management to wrap things up. All right. So first, let's start with our ACLs. I'm showing you this little cheat sheet. I don't know if you all are familiar with packetlife.net, but they have some phenomenal cheat sheets that give you an abundance of information to use when configuring Cisco-specific devices. So real useful information, especially when you're on the command line and trying to figure out exactly what you're trying to do based on the information you have available and the requirements that are pushed to you. In our scenario, we're going to configure what is known as inbound access lists. So why do we want to use access control lists? Up to this point, we have been enabling access between different parts of the network, but we may not want everyone to access every part of our network, which is where ACLs can certainly help us. So let's go to our playbook, and I will go ahead and open this up for you. Okay, so our playbook. Okay, for this playbook we are focused on ACLs, but here, again, I separated my devices into their own categories as I want to keep my host file as simple as possible. And copying and pasting is not that difficult, so to create an access list, in general, let's just say we were on a Cisco device. So to create an access list, we would do something along the lines of entering global configuration and then typing the command access list, and then obviously we would have to give it a number, and then once we created our access list, then we would actually have to apply that configuration to an interface, and that's where we would want to use the for instance, we would do an interface GI1, and then this is where we would implement an access group. Access expression. IP access group. Sorry, I've left out the IP command. And then lastly, we would need to apply that configuration for it to take effect. So Ansible will do all of those operations for us on multiple routers, and that saves us a lot of times. So as we look at this playbook, we see that I am using the iOS config module. And this is to implement my access list commands, but then after that I'm using the iOS ACL interfaces module to apply the access groups to my desired interfaces. Alright, and that would be here. In this case, I'm binding the configuration to my subvirtual interfaces that are servicing my local area networks. So we have two options when implementing ACLs. There is standard and extended. A standard ACL checks a source IP address and permits or denies an entire protocol suite, whereas an extended ACL checks source and destination IP addresses and permits or denies specific protocols and applications. Extended ACLs are more widely used in professional settings, which is why I chose to use it here. Because although I am focusing on simple IP addressing, I may want to add parameters in the future, so I'm giving myself that ability up front. ACLs can be named or numbered, and in my case I'm using ACL number 100, which indicates it is an extended access list. Okay, so we see I use the iOS config module to manually spell out my access list. However, I could also use the iOS ACLs modules to do this if I wanted to. It's just an option. It's another great flexibility of Ansible, which allows me multiple options to accomplish something and make it reusable. But for this instance, we will manually write out our commands, as they are probably more familiar to most network engineers when viewing them. So I've written out my ACLs and how I want them, and now I'm going to use the iOS ACL interface module to bind my ACLs to my desired interfaces. And in my case, my SVI is created on my router. I have VLANs on my switch to segment my traffic, but want to really make sure that my networks on my SVIs cannot reach each other whatsoever. I'm focused on routers 1 and 3, since they are servicing my LANs on each end, and that is what I'm targeting in my playbook here. Again, there are always ways to make your code more efficient and reusable, but I'm simply giving you one possible example of how you can accomplish this. Again, in my Cisco code, I always save my running config when my playbook finishes executing, and that would be here. So starting with router 1, it'll target that first, and then we'll move on to router 3. So let's go ahead and we'll start with router 1. So if I do, let's see, end here, and I do a show IP access list, I can see I do have extended IP access list 100, so let me go ahead and negate that. So no IP access list 100. Okay. Oh, what am I doing here? Oh, sorry. Extended 100. That's better. Alright, and then from here, I'll just go ahead and do this again. And I don't have any of those access lists. Alright, so now let's run this play. And what we did here, obviously, it's going to implement these access lists and then bind that configuration to my SVIs. So let's go ahead and run this. We'll go ahead and clear this out. So Ansible, playbook, ACL, and then we'll limit this to router 1, which is where we took away our ACLs. And then real quick, we'll bring router 1 back up. We'll actually let this do its thing. So just so you know, here we have the yellow text again that indicates that we did change something. It apply ACL to sub interfaces. Now notice that inside my router, when I did negate that access list, it did not negate the configuration on the interfaces itself. So that's in green because that didn't change. All right. But when we save the running config, obviously things did in fact change very much so. So when we come back to here and we'll run our show IP access list, notice that they're back. Okay. So what we'll do, just for sake, we'll do a no IP access list extended 100 on router 1, and then we'll go ahead over to router 3 and we'll implement the same. So I'll go ahead, we'll copy this, we'll get rid of that. Now let's come back to Ansible. Let's get rid of this limit command, and we'll go ahead and run this. And notice when we do run this, it's going to target router 1 first, and then eventually it will target router 3. Now, like I said before, ways to improve this code would just be to minimize the code that's occurring inside here, and then we could use the different aspects, such as the host file inside Ansible, to negate this into a simple group of hosts, not just one by one. And while the playbook will still execute one by one to each router, it will not have to go through each individual facet. It'll basically accomplish all of what you want on each device as it goes. So it trims the time down a bit, okay, if that makes sense. So we'll come back over to router 1 and router 3. Notice we have our open and close SSH section, and then we'll go ahead and show our IP access list. We'll come over here and show IP access list, and there they are. Okay, looks good. All right, let's talk about full configurations. Let's just say you have known working configurations that you have centrally stored, and you want to implement these configurations onto your network devices. This one is really too easy, but I will show you one of Ansible's magic words during this process. So let's look at our playbook, which we called in this instance configure sandbox devices, only because this is my sandbox. So here. Okay, I set this one up slightly different from the rest of my playbooks, and the way I did that is I numerically numbered my plays here. All right, this can be incredibly useful when running larger playbooks, especially if they fail. Reason being, you can track down the location of your failure as it's running by looking at which play number the playbook failed on. As I said before, Ansible is not well known for detailed debugging of code, so save yourself some headaches and number your plays. And what I mean is by play 1, play 2, and play 3. Okay, so all I'm doing here is using the iOS config module to call on a source file. All right, the source file being my configuration file. Notice the use of inventory hostname. All right, that's right here. That's that magic word I was talking about. Ansible uses this to check the host file, identify the host name in your inventory, and then grab that configuration file as desired, destined for its targeted device, which is both useful and powerful. So, the second piece of this, let's look at a cool little module called iOS Banner. All right, this guy right here. In my specific sector of work, the use of a login banner is mandatory. And this module will automate the configuration of this banner, which makes life a lot easier for me, especially on multiple devices. And then, as I always do in my Cisco playbooks, I save my running config when we're done. So let's go ahead and we'll run this playbook. But as you let me describe this here. So my source is inside of my directory. I have a additional subdirectory, sandbox configs. It will use this inventory host name, so R1, R2, R3, S1, S2. .ios is my extension. I like .ios, and I'll show you why in a second. So for example, so for R1 iOS, if you notice on the bottom right here, my language is Cisco. It's just an extension I get to install on VS Code, and it gives me cool little perks of viewing a nice Cisco configuration file, all right, which most network engineers will know and recognize. Okay, so what we'll do here, here's my directory where my playbook is going to target, and then it will hit my endpoint devices, which in my case are routers and switches. These are full. I have this commented out. These are STIG configs. We'll talk about that in a later video. So it'll spit its base configuration, and then we'll configure a banner, save the running config, and then we'll exit. All right. So let's just see. Now we're talking 5 devices, 3 routers and 2 switches. All right. So if you're a network engineer, I'm sure you understand how time-consuming it can be to configure 5 devices with full configurations. So let's go ahead and do that right now. We'll see how long it takes us. And like I said before, You can see here I have my play 1. All right, so if I did for some reason have a failure here, it's going to tell me where. And then I have my play 2, same thing with the login banner. And then I'm going to save my running config here. Okay, so in this time that it just took us to do what we needed to do, we configured 5 full configurations on network routers and switches. So it's fantastic. So what Ansible did was it SSH to each device. It configured the devices based on the source files, and then it exited. And it did it one by one, which is why Ansible may not be your best automated solution for larger deployments, but it's still very, very powerful. All right, so we've configured our devices. Now let's talk about how do we back up our network configurations to a centralized location. How many times has a network gone down and everyone realizes there are no saved copies of known good configurations? You don't think that happens? I can tell you that it absolutely does, and it's unacceptable as an excuse, especially with tools such as Ansible, which can be used as I'm about to show you. Alright, so what we're going to do is we're going to look at a playbook called DTG Backup, alright, which is called Date and Time Group. Now, if you wanted to see where Ansible is going to pull its date and time group, you can simply come to Terminal. We'll clear this out, and then we will filter for date and time. And Ansible has a built-in function to get your date and time. All right, so I'm going to use a built-in tool to get the date and time, then use that to separate my backup files into separate date and time directories, which helps if you're backing up daily or weekly or monthly, etc. So in this playbook, we're going to gather, let's go back to the playbook, we're going to gather the date and time from our controller. All right, we'll store it as fact, create a directory to store our files, that's here, back up our network devices, so essentially running a copy, running config to a backup directory, and output that backup data to a file of our choosing in our new directory. So notice we do not have a backup directory inside of our tree here. Okay, this is going to create one. And then, yeah, so it will actually label it by its date. Okay, which is great information. And then again, my file extension of choice is .ios. This can be used to configure Cisco devices, which I just showed you. So, you know, a mandatory .txt or a .cfg, it's not necessary. iOS works just fine. So let's run the playbook, and we can see how this works. So let's go ahead, we'll clear this out. Ansible playbook, and we'll do a DTG. Notice this is just doing my routers and switches, okay? So the first things first, we're going to get our Ansible date and time facts, localhost, which is our Ansible controller. We created our directory, which is great. So now we're in the process of doing that copy running config to, and then we're basically taking that output. So it's almost like a show run, and then taking that output and copying it to our Ansible controller. And as we can see here, the change was the directory was created, all right? And then obviously the output was saved here, so that's what has changed. So let's go back. Now we see we have a backups directory, all right, which is great. And inside of that directory, we have a subfolder. All right, the subfolder is today's date, November 2nd. And then we have each individual device backed up. So R1, and this is full configurations. All right, we're not talking little debugging output. Nope, this is full configurations, which we can use for later. R2, R3, S1, S2. Very powerful, all right, because now we have the ability to back up our stuff, so we should always have good known working copies of our configs, right? We should hope so. All right, what about our PCs? I'm sure you already knew, but Ansible is incredibly effective at managing Linux machines as well. I'm going to show you some very basic tasks that will definitely help you with this, but I will keep it brief with more to follow in future videos. All right, so let's go ahead and we will talk through what we want to do first. We'll talk about something easy and important, okay? Updating and upgrading your packages on your Linux box. All right, so in this case, I called my playbook update all. All right, so what we did was we targeted our Linux PC. All right, that's in our host file right here. So we have 4 PCs. Okay, and then what we're going to do is the equivalent of a sudo apt-get update, upgrade, auto clean, auto remove, and then a reboot. All right, that reboot makes sure that all of your upgrades took and that anything that you need to purge is gone. All right, so that's the equivalent here. And this is how simple it can be to update. We're going to do 4 devices. All right, so let's go ahead. We'll go ahead and run this. We'll clear this out. Ansible playbook, update all. We'll start this, and while we're doing this, we're going to go ahead and we're going to pull up our PCs. PC1, PC2, PC3, and PC4. All right. But while we're doing that, let's see how this is running. All right, so here we go. We have updates to all of our PCs. It's in the process of upgrading. Now notice, you're going to need internet connectivity for this one. And on top of that, if you had like a fresh install, this is going to take a while to run. Because, you know, Linux, it takes a while to go out and do all of those upgraded packages. So luckily, I do my updates and upgrades pretty regularly here, so it's not going to take too long. All right. So we had, in this case, sudo apt update, sudo apt upgrade, sudo apt auto clean, and then sudo apt auto remove, right? And now we're going to do a reboot. So let's go ahead and pull our PCs back up. Let's see what happens. All right. Are we going to reboot like we're supposed to? All right, so we're in that reboot process, and we should be there shortly. I'm going to go ahead and pause this so the reboot can execute. Or actually, let's give it a second. Where are we on our controller? Okay, so our reboots are in progress. It's just taking a little bit longer than I expected it to. Normally these reboot pretty quick. But I'll go ahead and pause the video to allow this to do its thing. Oh, there we go. Alright, so PC1 is in its reboot process. And PCs 2, 3, and 4 shouldn't be far after. Alright, good to go. Alright, and while these are rebooting, let's move on to our next subject. Alright, because all that's going to happen is these are going to come back up, freshly updated and upgraded. Wonderful. Alright, so the next portion of this, we'll talk about networking. Alright, so the last piece that I wanted to talk about as far as Linux goes is our interfaces. Alright, I am a super fan of the nmcli Network Manager Suite. I can use it on both RHEL and Debian-based distributions, and it works very well for me and my needs as a network engineer. All right, so if I wanted to do some kind of a modification to a Linux PC, and now that PC1 has rebooted, I can kind of show you what that looks like. So for if I wanted to view my interfaces, I could do a nmcli C. And this is going to give me information about my wire connection 1 and 2, which I've already set up. All right, but if I didn't know, I'd do a nmcli connection show, and then I'll do a wire connection 1. This is going to give me all of the information I need, okay? And it really is very powerful. So I can see I have my address. I have my host address, I have my subnet, and then I have my gateway. All right. On top of that, if there were any routes, I'm going to be able to see those as well. All right. I don't have any specific routes in this particular setup because I have a default gateway. All right. But it also tells me the interface that I'm using which is also powerful as well because that can always give you a hand in Linux. All right, so let's just say I wanted to modify this. All right, I wanted to actually modify this for my needs. So what I'm going to do, anytime you modify an interface in Linux, you're going to want to bring that interface down. All right, so the command would be nmcli connection down, and then your interface, as you can see, I'm using a reusable variable here, which is interface 1. And if I go to my host document, I see my interface 1, okay, that is this address right here, okay, but it's an underscore IP, okay. So coming back to this, we've also identified what interface 1 is. It is my wired connection 1, which I just showed you on my Linux box. Okay, so now we've brought it down. We want to modify it with wired connection 1 IPv4 addresses with my interface IP, again, identified in my host file. So it's going to assign a host address, okay? And then from here, it's going to assign a method. All right, so in this case, it's going to be static configuration, not DHCP. And then I give it a gateway. All right, and my gateway IP, again in my host file, right here. So each device can be targeted, and I don't have to rewrite my code over and over and over. Okay. Lastly, I'm going to bring that connection up, and then I'm going to do a reboot to make sure it survives. So let's go ahead and do that now. We will clear this out. Ansible playbook, Linux interfaces. All right, so this should go through and target each one of my network devices, or not network, but my Linux PCs. All right, so it's going to go ahead and deactivate that wire connection 1. Notice that we're not deactivating the interface which services our Ansible controller. All right, this is why I am a proponent of out-of-band management for any kind of network or host automation, because when you do things in line, it's this easy to deactivate your own connection. And if you only have half a configuration that's been done, well, that could get ugly. All right, we don't want that. All right, so lastly, we're going to go ahead and ensure the network is persistent and survives a reboot. All right, and just so everyone's tracking, the interfaces that we are modifying here are the interfaces that actually traverse our production network. Okay, so these interfaces here, and we're going to be going over a routed network using the OSPF protocol to have both of our local area networks work. Okay, and the one thing, let's see, where are we? Okay, so we have, okay, so our PCs have in fact rebooted. That was a little faster this time. But now, can we ping across? So our IP address here is 20.0.0.2. Let's see if we can hit 30. Ping 30.0.0.2. We sure can. How about 40? Can we do that? Yep. We can. Now, one thing I forgot to talk about with ACLs, the reason I did that is because I wanted to separate our traffic on our local area network. So let's see, did we actually accomplish that? So our IP address here is 20.0. Now, the other PC, PC2, is 10. So can we ping 10.0.0.2? We sure can't. That packet's being filtered out. Why? Because we successfully configured our access control list. This is just how powerful Ansible can be. All right, we've accomplished multiple operations with one single controller. We have backups of pretty much everything. In another video, I can talk about Linux backup, but for now, our network devices are all configured, fresh configs, fresh backups that are ready for us anytime we need them. And yeah, we're ensuring that we can talk throughout the network as desired. And what we don't want communicating with one another is being filtered. So that's exactly what we want to see. And I hope this was informative to give you a little bit more insight into how powerful Ansible can be. So thank you for your time, and I'll see you next time. Take care.